Yeah, thank you very much for inviting me to this great session. It's a great honor for me to be here. And as you know, the NTT DOCOMO is closely collaborating with your company, SK Telecom. And today, I'd like to explain our concept, our activities on the 5G evolution and the 6G first. And then I'd like to explain our collaboration with SKT. Okay, so this is a high-level concept of our 5G evolution and the 6G. Yeah, as you know, the cyber-physical system, cyber-physical fusion, metaverse, digital twin. Those are, of course, clear trend for the future. Even for now, we are creating the many new application services on the cyber-physical system, metaverse, digital twin. But those trends, those applications need to be advanced, improved so much for the future. In order to do that, we need to transfer the huge amount of data between the cyberspace and the physical space, and transfer very quickly, yes, so that we can create the new services for the future. In order to do that, and we set the 6 kind of the requirements, as you can see in the 6 box. Many of them, such as the high data rate capacity, low latency, reliability, those are further improvement from the 5G, I'm sure. Maybe 10 times or 100 times improvement to be needed for the 6G from the 5G. But new things, for example, your left center, yeah, extreme coverage. This should be a rather new. And yeah, even for now, the NTN, non-terrestrial network, is one of the very interesting topic. In the 6G era, of course, NTN should be a foundation, one of the foundation of our 6G network. And our terrestrial network and the non-terrestrial network need to be integrated for the 6G. And also left bottom, extreme low energy and the cost. Yeah, sustainable society is a very essential topic, even for now and for the 6G. Of course, we need to have some kind of drastic solutions, good solutions to improve the energy efficiency. And also right bottom, yeah, sensing is also one of the very interesting topic, and especially on the joint communication and the sensing. We believe that with this feature, we can create additional new services based on the joint communication and sensing. And DOCOMO is very aggressively studying and researching, developing the solutions for the 5G evolution and 6G. And 4 technical areas we identified like this. Left top, millimeter wave coverage improvement. We think that millimeter wave should be one of the very important topic need to be improved from the current situation. Yeah, millimeter wave is not so used in the world. Yeah, I know the Korean situation and the US situation. And but the DOCOMO has a millimeter wave spectrum band, and DOCOMO and other Japanese operator has a 28 gigahertz spectrum band for the 5G. But that was not so deployed yet. But millimeter wave has a very excellent capability in terms of the very high data rate and the low latency capacities. So we should use the millimeter wave more. And sub-terahertz, of course, one of the very interesting topic for the 6G. We have many technical challenges to deploy the sub-terahertz in the real cellular network, but we need to solve that. And coverage expansion, NTN. That should be key, of course. Especially, we are aggressive for all of NTN solutions, like ZEO, LEO, and also HAPS, yes. And underwater wireless communications, our parent company, Laboratories, are very aggressively researching this kind of technology and conducting the trials in the real, in the real ocean, yes. So that should be one of the very interesting topic to expand the coverage. And the industry use cases, this is, of course, very interesting and the important topic even for now. But for the 6G, of course, the further extension of the solutions and the services for the other industries, vertical industries. That should be very, very important, of course. But based on the 5G application solutions, maybe we need to improve the, and we need to create the new solution applications. And hopefully with the joint communication and the sensing, that should be one of the very interesting key technologies to expand the industry use cases. From here, I'd like to explain some of them. And first, millimeter wave and the sub-terahertz, higher spectrum band. And what kind of spectrum band could be a good candidate for the 6G? And that is a very interesting topic. And now, yes, WRC23 just started, yes. And maybe 6G spectrum topics will be treated as an agenda for the WRC27. And we think that this spectrum band could be a candidate, 7 to 24 gigahertz, especially 7 to 15 around. That spectrum band is a very, very interesting band. And many stakeholders and many countries interested in this kind of band, 7 to 15 or 7 to 24, I know. But still, we need, it's a little bit a complicated situation. We need to negotiate with many, many stakeholders, including the other industry people. Yes, not so easy to identify this band. And also sub-terahertz, 92 to 300 gigahertz. Yes, this should be, of course, one of the good candidates toward the 6G. But as I said, the technical challenges, there are so many technical challenges, and maybe this sub-terahertz will not be treated in this WRC23, and also possibly 27, I don't know. But technically and also politically, we need to address the sub-terahertz in any case for the 6G. And deployment image is like this, spectrum by spectrum. Yes, we use each spectrum band, case-by-case basis, even for now. And maybe, of course, the SK Telecom using the variety of the spectrum band, case-by-case basis. Maybe in general, low band should be a coverage band, mid band, maybe both coverage and the performance, millimeter wave, just for performance, not so for the coverage, of course. And in the future, if we can use the sub-terahertz, maybe we will deploy the sub-terahertz like that, yes, on top of the millimeter wave. Much super performance cell area can be created by the sub-terahertz, yes. From here, coverage expansion, especially NTN and the HAPS. We have mainly three kinds of the solutions, ZEO, LEO, and HAPS. We are already deploying the ZEO in the Japanese market and globally, of course. And but the distance is 36,000 kilometers, very long. So performance is not so high, yes. But the coverage is very wide, of course. And recently, LEO is a very interesting solutions, yes, even for you and us. And some of the services has already deployed, and some of the companies, LEO companies, are now targeting the direct access to the smartphone from the satellite. And the HAPS, we also had a strong interest in the HAPS. The distance is just 20 kilometers, very short compared with other solutions. So we think that we can achieve the very high performance in terms of the data rate and also latency. So in any case, it is very important to use these kind of three solutions case-by-case basis and also a best mix approach. Yes. So we need to study all of them, and what kind of use cases can be considered, we need to study about that. Yes. Especially HAPS, we think that thanks to the shorter distance, the performance can be high in terms of the high data rate and latency. If so, we can consider the many kind of the use cases, yes. And normally, so far, we used this kind of NTN solutions for the disaster case. We had so many disasters, including earthquake and the tsunami and so on. And but that is not so profitable. But if we can use the hubs with the high performance, we can provide very many kind of the applications, including the construction area support and support for the big event in the suburban, urban, rural areas, and also remote island and the ships, and also aircraft flight. So we can have a nice opportunity to get to increase the revenue. Yes, operator point of view. And from here, I would like to explain the joint communication and the sensing. This is one of the very, very interesting topic for the 6C. And yeah, actually, several kinds of the approach we have for the sensing. Yes, radio, ultrasonic, infrared, and camera. But I think, as you can see in this table, the radio is a very good approach for the sensing in terms of the accuracy and loss, cost, and also privacy. And if we can use our network for the sensing also, not only for the communications, but also the sensing, that should be a very cost-effective, and then we can increase our revenues thanks to the new services applications. We can consider many kinds of the use cases by the joint communication and the sensing, and I know that that use cases are already under discussion in the 3GPP, and I know that a huge amount of the use cases are already contributed from the many companies in the 3GPP, and these for some of them, yes, we see that interesting. And for example, detection of the invasion to railway, especially local railway companies had a difficulty to invest and improve the railway system. And it is very difficult to allocate the human resources with that should be additional cost. So if we can detect that invasion like a wild animal on the local railway, maybe we can take some actions in advance to keep the safety. And also congestion detection. Of course, this would be a good example of the use cases in many of the event venue, store, shops. Yes, this kind of the congestion detection application should be very useful. And the behavior health monitoring, and for the safety safe society, maybe this use cases could be good for the humans' safe life. And the local rainfall estimation. Now, all over the world, yes, the serious heavy rain disasters, it's very, very serious. And if we can detect the heavy rain, serious heavy rain beforehand, we can take some actions, yes. So maybe not only these kind of use cases, we can consider many kind of use cases of the joint communication and sensing. We operators can create new services with this, I believe. And for operator point of view, it is very important to what kind of the network architecture should be considered for the joint communication and sensing, or all of the sensing applications. Actually, we have many kinds of the sensing capability solutions, not only the joint communication and the sensing, and we can set a variety of the sensing devices in our network facilities, of course, and also we can use the hubs or satellite for the sensing also, with a camera or something. And yes, those kind of data, of course, need to be transferred to our network, and especially we operators already have a MEC server. Yes, maybe you also, SK. And we have a very nice data based on from our subscribers. And if we can combine, or if we can integrate, or what can I say? Yeah, combine those kind of data, maybe we can provide new services, applications to our customer partners. Yes, very quickly. So combination with our operators MEC and sensing devices, that's very essential to provide new services and to increase our revenue in the future. Yes. Network architecture. Yes. I showed 4 kind of areas need to be addressed as a network, 6E network architecture. First one, 6E core as an enhancement of the 5G core. Yeah, many people now thinking about what the 6E core, and we really need to have a 6E core. But we see that it is clear that the operator point of view, yeah, we introduced a 5G core recently, and it is not so good to replace our 5G core to the new core network in the 6E era. Of course, we should use a current 5G core even for the 6E era. So, and also in the 5G core, we define the service-based architecture. That should be nice. And we should use the 5G core for the 6G continuously and with some kind of enhanced technologies, solutions. On the other hand, RAN core refactoring and new interface between the RAN and the core network is needed or not. That should be discussed. At this moment, it is not so clear. New interface need to be deployed for the future, but we should consider that. And also network automation, operator point of view. This is a very key topic, of course, even for 6G. We need to take care about the intent-driven management, data tree, and end-to-end orchestrator. And in network computing, that is some kind of MEC enhancement. MEC should be, of course, very important and need to be enhanced. And our network is not only for the communication, but also the computing, yes, now. And that will be more important. So we need to consider that. And the migration, yes, we operators don't want to have many kind of the options for the network migration like we had for the 5G introduction. So many of the stakeholders, everybody say that we should have a very simplified migration scenarios. Yeah, that should be true. Okay, so that's our concept and activities on the Beyond 5G and the 6G. From here, I'd like to explain our collaboration, SKT DOCOMO collaboration for Beyond 5G and the 6G, briefly. And we started our collaboration from the November last year. Yes, now just 1 year, yes, ceremony timing. And we agreed to collaborate on the 3 topics in media, metaverse, and 5G evolution and the 6G. And especially I and SK Telecom Takehiro-san is leading the 5G evolution and 6G working group. And we successfully published the white papers on the 5G green mobile network and the 6G requirement. That was published at in February this year. And 5G green mobile network white paper, yes, yeah, SKT has a very excellent knowledge and skills on the energy efficiency topics. And based on that, and also we measured the power consumption of the existing base station equipment, and we found that some kind of opportunity to achieve the greater power saving. Yes, so we had much rooms to save the energy. Yes, so that could be one of the very excellent results of our activity collaborations. Others also, other topics are included in our white paper like this. And also 6E common requirements. And we studied and discussed on the 6E common requirements. But actually, so many white papers has already published all over the world. And but we took a unique approach that we tried to identify the 6E common requirement based on the learning from the 5G. Yes, we had many important points need to be addressed for the future 5G or 6G based on the learning from the 5G. We experienced so far. So we defined many kinds of the requirements like this. I would like to skip the detail, but that was so nice studies and results to clarify the 6E requirement as a biggest operator in Japan and Korea. Especially spectrum topics are very important. And yeah, as I mentioned, we see some kind of the new spectrum band for the 6E. But it is important to clarify the use cases and also performance target for each spectrum band. The spectrum band by spectrum band, deployment scenario, the target performance should be different. So it should be clarified and it should be identified among all of the stakeholders. And we captured those kind of topic in a white paper like this. So as a conclusion, yes, in any case, we published a white paper that should be that was so impressed activities and result of our collaborations. That was so accepted in our industries, yes. And we will continue our collaborations, of course, and hopefully we can have a more excellent results of our collaborations. And that could be useful to promote or proceed our 6D studies and leading the 6D studies in the world. Okay, that's my presentation. Thank you very much for your attention.